Let's talk a little bit more about the hydraulic abstractions. We're going to be talking about evaporation, transpiration, interception, and infiltration in this video. Now, when we're talking evapotranspiration, we're just basically talking about the heat, removing the amount of water on the Earth's surface. So I'm going to let you read through this slide. I'm not going to go over it as much. There are some areas that where evaporation is really important. We look at it more for the agricultural aspects than we do for some type of subdivision design for ponds or land development design. So I'm going to go ahead and let you look at this. These two videos here are actually really kind of cool. It shows you how evaporation occurs depending on how much of the water is either in a ponded area or it's spread out over a surface. But that's kind of cool. It gives you a visual effect of what evaporation looks like. Now, transpiration is basically, like I said, when we're looking at, and I'll turn this little video on, when we're looking at the evaporation and transpiration through, and sometimes it's called evapotranspiration. Again, it's more for the agricultural use, is when we're looking at vegetation, how much of the water gets evaporated so that it's not accounted for runoff. I'm not going to go over this in this class, but go ahead and take a look at this slide and kind of get familiar with what transpiration or even evapotranspiration is. All right. Interception is a big one depending on how you're looking at it. We don't actually account much for interception unless it's something that's a large scale, like rooftop buildings that have trees or vegetation. So they're actually absorbing a lot of that water and it's not getting back into our stormwater management system that we have to design for. So we don't have a large number that's being used for this for calculation purposes. Usually we're just, it's such a low number that we don't account for. It's just one of those more tedious values that doesn't give us a lot of benefit to calculate it individually for each site. Because here's the other thing, what the site looks like to begin with isn't what the site's going to look like to end with. Like it could be a rural farm and we're turning it into, an upscale subdivision with a lot of parking areas. So we don't use this one as much. But go ahead and read through the slides. It's really interesting. Infiltration is a big one that we do use. I'm going to go ahead and turn this one on. Soil permeability, there's certain things that you look at when you're talking about permeability in porosity. So in this video, they're actually showing you different types of soils or materials that they're going to put into these beakers. So think of infiltration as like a sponge. So water gets put into water goes into the ground and it can be absorbed into the land. Depending on what type of material the ground is made out of, you have different absorptions. So in the video they're showing you is the different types of material. The first one has gravel, the next one has soil, the next one has sand, and the other one is regular, the last one's clay actually. What they're showing you through here is the various time it takes to send a certain amount of water through the materials. So depending on the type of material that the ground is, whether the type of soil and then the cover over the top of the soil actually has a really large effect on how much water is going into the ground. So if it's got a really dense grass over the top of, some type of sandy soil, it's going to have a really big permeability rate or infiltration rate. Whereas if you have, something that's asphalt over, clay, it's not going to be seeping into the ground very fast. So the vegetation cover, the type of material that the soil is made out of. There's also a thing called the antecedent moisture condition. That means when was the last time that it rained? If it rained just yesterday and we're trying to put more water in the ground, it's not going to seep into the ground because the ground is already saturated and no more water will go through. So I suggest you take a look at this slide, read through it. It's one of the more important slides and one of the bigger pieces of information that you'll need in the design of runoff. We'll go ahead and go to the next one. This one basically goes over the rate of infiltration. So this is the end of that video that I was just showing you. There's gravel, light soil, fine sand, and clay. And if you look at these, it says that the gravel goes, how much water that was put into from that beaker in, 93 milliliters of water goes through at a rate of 1 minute and 49 seconds. Whereas the next one, the light soil, only 53 millimeters of water went through, and it took 2 minutes and 56 seconds. For the fine sand over here, it had only 49 millimeters of water go through, and it took 3 minutes and 21 seconds to drain. And then you have clay. Clay, no water went through, and it took 9 minutes and 19 seconds, and they just stopped. What that's showing you is, depending on the different types of soil, clay has more runoff potential than gravel will, because clay isn't allowing any of the water to go through the ground into the ground. Okay, so take a look at this slide here. It's got a lot of good definitions that we'll be looking at throughout the semester. Again, this one is the same slide, but these two are the definitions that I want you to pay specific attention. Porosity is about the size and the shape of the packing materials. So this is going to have more porosity than this, where the particles of various sizes and shapes, we tend to have less porous soils. Permeability describes the rate of infiltration into the ground by water. That means when if you pour water over a sponge, it'll absorb the water because it's very permeable. Now, most of our soil conservation books are going to tell us the porosity and permeability of the soils, which in turn tells us how much infiltration the ground is going to take of that runoff or of that precipitation coming down. As a recap, of the hydraulic abstractions we've talked about so far, the most important one is infiltration. We'll go ahead and talk about storage and runoff in the next set of videos.